Hello students, welcome to class 10 ICSE board physics. We are with numericals episode 1.1 and we are solving numericals for the chapter forces, turning forces and uniform circular motion. So far we have completed numericals from 1 to 4. In this episode we are going to complete the rest of the numericals. So let us move on to our topic. So we are starting with question number 5. Study the diagram alongside carefully and calculate the resultant moment of force about point P, point Q and about the point R, which is exactly in the middle of the two forces. Now before you go into the solving the numericals, you require to observe the diagram carefully. If you see P, then F1 force acting on it, which is 20 Newton, has 0 perpendicular distance. But if you talk about F2, then F2 has a perpendicular distance 20 centimeter. So this is for P. For F1, the perpendicular distance is 0, but for F2, the perpendicular distance is 20 centimeter. I am going to change the color for Q. If you see Q for F2, then perpendicular distance is 0. But if you see for F1, the perpendicular distance for Q is 20 centimeter. But exactly in the center is a point which is R, and on R both the forces are going to work with a distance of 10 centimeter and 10 centimeter. So when we are working out for point P with reference to F1, perpendicular distance is 0. So if you see here, moment of force due to F1, perpendicular distance is taken as 0, so it is 0. But for F2, the perpendicular distance is 20 centimeter, so that means 0.20 meter, that becomes 4 Newton meter along with the force. So 4 Newton meter along with the force, 20 Newton. Now resultant force for F1 and F2, it is 4 Newton meter in clockwise direction. Same thing for Q1. Same thing for Q. F1 is the force which has acting at a perpendicular distance of 20 centimeter. If you calculate in Newton meter, you get 4 Newton meter. But for F2, perpendicular distance is 0. Therefore, the moment of force about Q due to F2 is 0. If you add both F1 and F2, you get 4 Newton meter in clockwise direction. But for R, if you see R, then R is exactly in the center. So the distance from the center to F1 and F2 is 10 centimeter, which comes up to 2 Newton meter clockwise direction. And the resultant force for F1 and F2 will be 2 plus 2, 4 Newton meter in clockwise direction. So it is simple. The thing is that you require a proper understanding of moment of force. I hope you understood this sum. Let us move on to practice problem 5. I am going to solve question number 1, question number 2 and question number 3 will be your homework. So here answer practice problem 5.1. If you see the diagram, F1 is equal to F2 is equal to 5 Newton and the perpendicular distance is given is 1.2 meter. So moment of force is equal to, in anti-clockwise direction, is force multiplied by perpendicular distance, that is 5 multiplied by 1.2 meter, 5 Newton multiplied by 1.2 meter. So that will become 6.0 Newton meter. So it's simple and I hope you understood this problem 1 of practice problem 5. Let us move on to the next one. So question number 6, a uniform meter scale is balanced at 40 centimeter mark when weights of 25 GF and 10 GF are suspended at 5 centimeter mark and 75 centimeter mark respectively. Calculate the weight of meter scale. So I am going to do this one here once again. Even the solution is given. So here this one is 0, This one is 100. The center point, that is 50. Here one weight is suspended. That is what we have to find out. So W. At 40 centimeter mark, the scale is been balanced. The scale is balanced at 40 centimeter mark. At 5 centimeter, the weight is suspended is 25 GF at 5 centimeter, and at 75 centimeter, another weight is suspended, that is 10 GF. Now, this moment will be clockwise direction. So moment in clockwise direction, and this moment will be in this direction. So it is moment in anti-clockwise direction. So before we go further, we have to find out the distance, that is from fulcrum to the suspended weight. So this is the point at which the meter scale is balanced. From here to here, the distance is 35 centimeter. From here to here, the distance is 10 centimeter. From here to here, the distance is 35 centimeter. So here it will be 25 multiplied by 35 centimeter GF is equal to 10 multiplied by W plus 35 multiplied by 10 centimeter GF. Now this one comes up to 875 GF centimeter or centimeter GF. So either GF centimeter is equal to 10W plus 350 GF centimeter. Okay, 350 goes this side, so it becomes minus. So 875 minus 350 GF centimeter is equal to 10W centimeter. So here it comes up to 525 upon 10 is equal to W is equal to 2.5 GF. So I hope you understood the sum. This is the way we do question number 6. I'm going to solve question number 1 of practice problem 6. Please pay attention. It is pretty simple. And question number 2 and question number 3 will be your homework. So I'm starting with practice problem 6, question number 1. So here, so if I want to use, I can use this part. Okay, so first of all, your answer. Answer is practice problem 6.1. It says a uniform meter scale is balanced at 60 centimeter mark. So we will have scale 0, 100. This is 50 centimeter. And at 10 centimeter away from it, that means it is 60 centimeter. The balancing is done. So meter scale is balanced at 60 centimeter mark. Yeah. 5 GF and 40 GF are suspended at 10 centimeter. So here 10 centimeter, here this is 5 GF. Okay, let me draw it a little bit short. Here 5 GF. Then you have to find out the distance between this one and this one. So it is 50 centimeter. You have to change the color. So from here, this will be W. So from here to here, it is 10 centimeter. Now another weight is suspended at 80 centimeter mark. So here 80 centimeter. And there is another suspension is there of 40 GF. And the distance between this one and this one is 20 centimeter. Now this one is going this side, this direction. That means it is anti-clockwise direction, and this one is moving this direction, so it is clockwise direction. So moment in clockwise direction, so I write moment in anti-clockwise direction and moment in clockwise direction. So that is equal. Now here 5 multiply by 50 plus 10 multiply by W GF centimeter is equal to 20 multiply by 40 GF centimeter. So here it comes 250 plus 10 W is equal to 800 GF centimeter. This one is also GF centimeter. Okay, now 250 goes this side, so it becomes minus, and 10 goes down. So W is equal to 800 minus 250 upon 10 GF. So W is equal to 550 upon 10 GF. So W is equal to 55 GF. So I hope you understood this sum. It is simple. The only thing that you require to know is the proper analysis and the diagram of the problem. If you draw the diagram properly, then it becomes really easy to understand the given numericals. Okay, we'll move on to the next one. I think that will be the last part of these numericals. So we'll move on to question number 7. Question number 7 says a uniform meter scale of weight 50 GF is balanced at 60. So at 60 the balancing is taking place. When a weight of 15 GF is suspended at 10 centimeter mark, so at 10 centimeter 15 GF is suspended, where must be the weight of 100 GF to be suspended to the balance of a meter scale. So balance is done on the other side of the point of equilibrium. So it is between 60 and 100. Where will be the another 100 GF weight is suspended at what centimeter? Suppose we say if it is at this centimeter, so it will be X. So 60 minus X, or you can say X minus 60, because X will be the greater than 60. So it is X minus 60, and then 100 GF would be suspended. The distance between the 50 and 60 is 10 centimeter. This is the direction of the weight that is acting, which is anti-clockwise. This is also anti-clockwise, and this is clockwise. So if we use the same sort of a method, that what we are doing. then it becomes easy to find out at what distance the weight 100 GF is to be suspended. Then if you calculate, we get 72.50 centimeter is the distance where is the point where 100 GF is of the weight is suspended in order to bring the equilibrium in the uniform meter scale. I'm going to solve question number 1 of practice problem 7 and rest of the questions that you have to solve it. So let us move on to the practice problem 7. It says a uniform meter scale of 50 GF is balanced at 40 centimeter mark. So uniform meter scale. So first of all we'll draw the diagram. Okay, before draw the diagram I require to write. So I will write answer practice problem 7.1. So uniform meter scale of 50 GF. So here 0 and here 100. And it is balanced at which mark? 40. So this one is the middle. Okay. And here it is 40 where the suspension is there, so that the meter scale remains in equilibrium, or you can say in balance. 40. The weight here is 50 GF. When a weight of 100 GF is suspended at 5 centimeter, so here 5 centimeter, 100 GF weight is suspended at 5 centimeter. Where must be the weight of 80 GF? So here X. GF must be suspended to balance the meter scale. So now I'm going to take the another color. So here, from here to here, it is 10 centimeter. From here to here, X minus 40. From here to here is 35 centimeter. This one acting in this direction, this one is acting in this direction, this one is acting in this direction. So this one is moment in anti-clockwise direction, and this one is moment in clockwise direction. Here 35 multiplied by 100 GF centimeter is equal to 10 multiplied by 50 plus 80 multiplied by X minus 40 whole thing is what? GF centimeter. Open the bracket and you get 3500 GF centimeter is equal to 500 plus 80x minus, here you get 3200, that is 3200 GF centimeter. Now 3500 minus 500 plus 3200 is equal to 80x. So now from here 3500 minus 500, so that is going to be 3000 plus 6, 3000 plus 3, 3200, that is 6200 divided by 80 is equal to X. One minute. this one comes up to x is equal to 77.5 centimeter. So this is our answer. I hope you understood this sum. So it is pretty simple, it's easy, you can work it out very nicely if you draw the diagram. So if you see this video 2-3 times and understand what it's trying to say, then it becomes really easy to solve other questions. Solve question number 2, 3, 4 likewise, and then we'll work it out with the other. Thanks very much guys. I hope you understood the whole session. If you have any doubts or any questions, please let me know in the comment box. Thanks very much guys, and see you later.